In this chapter, we are going to be talking about an application of calculus, which is to optimize a targeted function. So here, we can use derivatives to maximize or minimize a function. And the points where those functions are maximized or minimized are called relative extrema, namely relative maximum or relative minimum. A relative extrema is the x value that makes the first order derivative equal to 0. This is where the function has no slope or has a horizontal tangent line to this point, okay? And this occurs where the function is at very maximum or very minimum. Let's look at the following graph. So, as you can see, when the second order derivative is smaller than 0, that means this function is concave, right? Originally increase, eventually decrease. Namely, the slope of the tangent line is originally positive, big positive, eventually approaches to 0, and then starts to fall down. So this first order derivative is constantly decreasing in x. That means the second order derivative is smaller than 0. Okay, so for a concave function, now as we are drawing out this graph, we can see we do have a maximum point, and this point is called relative maximum. Okay, and here, when this maximum is achieved, that is when the slope of the tangent line equals to 0, namely the tangent line is horizontal. That's why we are seeking the condition where the first order derivative equals to 0. Solving this, then we can solve for x that maximizes this function fx. Similarly, for a convex case where the second order derivative is greater than 0, okay, so originally, as you can see to the left of this V shape or U shape, right, the slope is negative and it's big negative. Then approach to 0 when we are approaching to the bottom of the valley, and the tangent line starts to grow, and when it's positive x, a big x approaching to the infinity, right, then the slope is very steep positive. So here, as you can see, the first order derivative, which is the slope of the tangent line, was originally negative big number, eventually approaches to 0, and then starts to grow, and eventually when x approaches to infinity, the f prime x grows to a large positive number as well. So throughout the process, f prime x, which is the slope of the tangent line, is constantly increasing in x. So that's why the second order derivative is greater than 0, but still, when you are to find the minimum point, as we see in the graph where my cursor is, what you're going to do is to solve this condition where the first order derivative equals to 0 on the graph. That is when the slope of the tangent line equals to 0. So the first row of this table is called the first order condition, and the second row of this table is called the second order condition. The first order condition is to make sure that the x that you solve out is a relative extremum, and then you're using the second order condition to determine whether this extremum is a maximum or a minimum, according to the curvature by nature of this function in question.